Question 10 is on differentiability and the power rule. So we just talked about things being differentiable, things being continuous, right? We said continuous functions aren't always differentiable, but differentiable functions are always continuous. We just talked about that. Okay, so there's 4 functions here, and these are important functions to keep in mind. So I told you f of x equals the absolute value of x, so y equals absolute value of x is important because it is continuous, but not differentiable at x equals 0. So it's not differentiable right there because our slope on the right was 1 and our slope on the left was -1, and it's not tapering off to like a slope of 0 or anything. So our slope is undefined at 0. Same idea for x to the 2/3. So x to the 2/3 has what we call a cusp, and so its slope is undefined at 0. And if you think about just the slopes on the left and the slopes on the right, the slopes on the left are negative and the slopes on the right are positive. It doesn't taper off to 0. All right, a vertical tangent, like y equals x to the 1/3, the cube root of x, this slope is undefined as well because it's a vertical tangent. We know that vertical lines have a slope of basically infinity, right? It's so steep that we have no words for it. It's undefined. All right, and then a discontinuity like in the Heaviside function. So the Heaviside function was created by a mathematician with the last name of Heaviside, as I've told you. And it's one where it's heavier on the top than it is on the bottom. I know, I should make up some kind of function, I don't know. All right, so a discontinuity like in the Heaviside function. So this one is, even though our slope is 0 here and our slope is equal to 0 here, our slope at x equals 0 is still undefined because it's not a continuous function. So we can't have a slope at a point or at a discontinuity. I don't want to say a point that doesn't exist because there is a point right there, right? It looks like there should be a slope at 1, but there's no slope on the left side of it. It's like if I was drawing a tangent line, do I draw it like this? Do I draw it like this? Do I draw it like this? I don't know. So think about that for your endpoints. Okay, so find all points in the domain where f is not differentiable. So you should know what this looks like. You've had algebra 2, you've had pre-calc. This is an absolute value function, it's a V shape. It's been shifted where?
5 and to the right.
Right 3 and up 5. Perfect. That's the vertex, 3, 5. So find all points in the domain where it's not differentiable. It's not differentiable at the point 3, 5. So I would say not differentiable
Use the hat symbol.
at x equals 3. For not, is that what you're saying? Not differentiable?
No, like the word at.
Oh, at, yeah, I thought you said hat. So there's something called hat in math, which is, I don't know, like, it's fine. I'm not going to go there. But it's like p hat. Have you done that in statistics and stuff? Okay. But there's also a bar, and bar means not, so I thought you were getting a little confused. Okay. So the calculator will actually compute what we call numerical derivatives for you. But the calculator is only as smart as the programmers that have made the calculator work the way that it works, okay? So a calculator, what they're doing when they do the n-deriv function is they basically have a curve, and they have a value a, and they're going slightly to the right of a and slightly to the left of a by 0.001. Okay, so if I had a equals 2, I'd put in 2.001 and 1.99. Okay, does this make sense? That's what my calculator's doing for me, 1.999. Okay, so I'm going to show you how this calculator works, and we're rarely going to use it. But on the AP exam, like on the calculator section, there might be times when it's just faster to use it. I don't know why I went to y equals. Okay, so on our main screen, I want you to hit math, and you're going to go down to n-deriv. It's math 8. And you're going to hit enter. Now, my calculator is a little bit older, and so when I hit n-deriv, it brings up the words n-deriv. Your calculators probably don't. Your calculators are a little bit newer.
Mine says in.
Oh, does it? It says n-deriv? So it's going to say one of two things. So I'm going to show you what it's going to say here, and I'm going to do this way first. So you put in the function you're trying to take the derivative of. So we're trying to take the derivative of x cubed. So I'm going to do x to the 3. And then I do a comma. I say, okay, I want to take the derivative with respect to x. Single variable calculus, so do comma x. And then plug in the x value you're trying to take the derivative at. So 2, and then hit enter. So it tells me 12.000001. Now, if you have a newer version of the calculator, here's what's going to pop up. It's going to say d something. It's going to have a parenthesis, and it's going to say x equals like that. Okay? You want to take the derivative with respect to x, so you're going to put an x here. And the function you're taking a derivative is x to the third. And you're going to take it at an x value of 2. So that is read, the derivative of x cubed evaluated at x equals 2. Okay? Did you still get the same thing? 12.000001. Huh? Comma 2. And you can end the parenthesis if you want to, or just leave it off. It's fine. Okay. Your calculator is lying to you. That is not the slope at 2. What do you think the slope probably is at 2?
12.
It's 12. So you can go through the whole, like we haven't learned that shortcut quite yet. Today's the lucky day. We get to learn the shortcut, guys. Very exciting. But if I did do the work and I did limit as x goes to 0 and I did x plus h cubed minus x cubed over h, I would FOIL out or multiply out x plus h times x plus h times x plus h. Anna's looking like she's going to puke right now. We're not going to do it. I'm going to write dot, 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 and you would get 3x squared. That would be what y prime is, or f prime of x is. Okay, so then what is f prime of 2? We would plug in 2 into 3x squared, and we get 12. Okay, that's our slope. So by hand, we would actually get the exact value. With the calculator, sometimes it kind of lies to us, but usually it's pretty darn close. Usually you can tell. All right, so it says find the derivatives of the following function using the formulas. So I had the first class divide up, and one group did one thing, one group did another thing, and then it ended up one group had a really hard thing. So we'll just power through this together. So f prime of x is going to be the limit as h goes to 0. This is the last time, these last 4 problems, this is the last time we're ever going to have to do this. It's very exciting. I mean, you'll probably have to do it on the test, I'm sure. But so we're going to have f of x plus h. Was there an x value there? So if I had like f of x equals 5, what's f of x plus h?
5.
No, it's just 5. There's nothing that we're plugging in x. Like, I'm not replacing x with anything. It's still just 5. So this would be c minus c all over h, which is the limit as h goes to 0 of 0 over h. What's the answer?
0.
I know. Everybody in the first class was saying undefined as well because they're like, it's 0 over 0. It's actually 0. Because remember, you're doing like h goes to 0. It doesn't actually have to equal 0. So if I plug in like 0.1, 0.01, 0.001, it's still just 0 over that number. So it's still just 0. So what we just showed is like the derivative of a constant. So if I have like y equals 7, its derivative would be 0. That's what we just showed. So you could go through all that work. All right, so let's say on the next one. So if I want to find f prime for this, and I want to do f of x plus h minus f of x all over h. X plus h, f of x plus h would be what? I just said it. X plus h minus x all over h. I'm forgetting my limit, aren't I? See, this is nice, so I can just squeeze it in there. So the limit as h goes to 0 of all that. X minus x goes away. So I get h over h. So imagine plugging in 0, 0.1, or sorry, 0.1, 0.001, 0.0001. What am I always getting? 1. So what did we just show? We showed that if I had y equals x, its derivative is 1. All right, the next one, f prime of x. Limit as h goes to 0. I want to do f of x plus h. So what I'm doing is x plus h squared minus f of x is x squared. And sadly, I have to FOIL things out. So I get x squared plus 2xh plus h squared minus x squared all over h. And some stuff happens. X squared minus x squared goes away. So I get the limit as h goes to 0. And I have 2x plus h. So as I plug in h goes to 0, 2x. So we just showed that if y was equal to x squared, its derivative is 2x. And here's the one that was annoying for the one group that had to do this, which would have been your back table there, Ari and Lydia and all of you. You would have had this. All right, so f prime of x is going to be the limit as h goes to 0. We would have x plus h cubed minus x cubed all over h. And we talked about this the other day. You guys remember I was like, oh, remember Pascal's triangle? You can do an expansion with Pascal's triangle. Or you could multiply it out 3 times. So you can do x plus h times x plus h times x plus h. Do we want to do that?
Yes.
You can. I'll tell you what it's going to be, because I'll do the Pascal's triangle thing. It would be like 1, 3, 3, 1. And our x cubes would go down. So it starts out with x cubed. And then I would do x squared. And then x. And then my h's go up. So no h's, 1h, 2h, 3h. That's how you can expand that without multiplying it all out. So if you're multiplying this part out, you would have to do x squared plus 2xh plus h squared. And then you would multiply this in as well. So then you take your x squared times everything, you take your 2xh times everything, you take, I mean, it's
So
longer.
So that's whenever you have a binomial, you can do that 1, 3,
Yeah. So if it was like to the 4th, it'd be 1, 4, 6, 4, 1. Uses that row of the Pascals. Okay. I mean, as I told you, it's not really like important to calculus. We're not going to do it like a lot. It's because it's this row of Pascal's triangle. So if I had like x plus h to the 4th, it would look like.
Why isn't it 1, 4, 5?
Because you add the 2.
Man, did Maury not teach you this at all?
Oh.
He did not.
You did.
I remember this video.
You did what?
I remember this because I thought it was really fun. I made a
don't.
giant one.
I don't remember.
That's what the expansion for x to the 4th would be. It's much easier than doing like multiplying it out by hand.
Wait, so would the next row, would the middle term be
So 1, 5, 10, 10, 5, 1. So the next one would be x to the 5th plus 5 x to the 4th h plus 10 x to the 3rd h squared plus, and so on.
No. What?
One goes up, one goes down. All right, guys, we're not spending any more time on this.
Is it 15 after that? 1. Is it 1?
1, 6, 15. 20, yeah. You get it. All right, so anyway, so I expanded that part, but I still have that minus something, so don't forget the minus something. So it was minus x cubed on the end. So now our x cubes go away, h goes into everything, dot, 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 it ends up being 3x squared. So if I had y equals x cubed, its derivative is 3x squared. It's not much longer to do that. I just wasted way too much time on binomial expansions. Okay, so there's a bit of a pattern that's going on. You may not understand like what pattern's going on, but let me give you some. So if I had y to the, not y to the 4th, y equals x to the 4th, its derivative, 4x cubed. I keep doing y to the 5th. If I have y equals x to the 5th, its derivative, Abby, 5x to the 4th. If I have x to the 99th, its derivative, ah, good. Are we all seeing it?
No.
The power goes to the front,
I hate this.
and it's 1 degree less.
That's awful.
Do you see it? Okay, now question though. If I have 10x to the 3rd, its derivative, any guesses on this?
30.
30x to the 2nd. Yep, you've got to multiply by that constant out front. All right, that is called the power rule. The power rule is pretty crucial in AP Calc unless you really want to do things with the limit as h goes to 0 every single time. As fun as that sounds, do we like the power rule?
Yes.
The power rule is amazing, isn't it? So the derivative of a constant we said was 0. And that kind of makes sense because if you think about what the power rule, if I have y equals 5, isn't that 5x to the 0, no x's? Does that still work? 0 times 5, x to the negative 1, yeah, it's still 0. All right, if I have, whoops, so I was on the eraser. All right, so if I do x to the n, it's going to be what for its derivative? N, x to the n minus 1, exactly, that's the power rule. If I have a constant, I really just don't worry about that constant. So when I had that one that was 10x to the 3rd, it's kind of like I kept the 10 to itself, and then I just did the derivative of x cubed. I said it was 3x squared, right? And then I just combined them, 30x squared. So it's going to be, just keep your constant out front, and then we're going to do f prime of x. I'm putting my two notations together in my Leibniz, in my Newton. Is that okay? Does that break all the rules? All right, this next one, f prime of x plus g prime of x, and f prime of x minus g prime of x. So products and quotients don't work this way. So for instance, if I had x cubed, what's its derivative?
3x squared.
3x squared. Well, isn't x cubed the same as x times x times x?
Yes.
So could I just say, oh, the derivative of x is 1, the derivative of x is 1, the derivative of x is 1?
No.
No. Illegal, right? We can't do that.
One.
So that doesn't work. You can't do that. So don't break it up like that. We'll do something next time, which is product and quotient rule. Let's skip the proof of the constant multiple rule. It basically has to do with limits. Do you guys remember with a limit, you can pull a c to the front, like constants to the front? You better not have just said, what's a limit? All right, so number 1. F prime of x is 0, because it was like 5x is 0. All right, f prime of x is equal to 18x to the 8th plus 0. So it's just 18x to the 8th. Do you guys get this?
Yeah.
Anna? This is like x to the 0. Okay, constants, their derivative is just 0. Let's think about why this is slope-wise. What does f of x equals 7 look like? A line through 7, right?
There are 4 slopes.
What's its slope? 0. Right? Does it make sense? All right, so 18x to the 8th. What about this one? So everybody write it down. Let's write it down. Hang on. Write it down. Think about it. See if we all have the same thing. Negative 15 x to the, Alexa,
X to the
4th plus
40 x to the 3rd plus 4x
to the
to the
negative 3. You were so close. All right, why is it negative 3?
Because then you have to minus.
We're subtracting 1 from the power. Negative 2 minus 1 is negative 3.
I was really close.
You were really close. All right, what do we think for the next one? What do we have to do?
Multiply by -2.
Yeah, you multiply the negative 2 times negative 2. Yeah. Okay, the next one. So far, so good, right?
Simplifying that then?
No, you just leave it like that. That's fine.
Because you can break, right? You can bring the 4x.
No, we're not going to do any of that. All right, so number 4.
Um,
So we only know this power rule thing, right? We need to see things, so it's like x to a power, right? So what do we think we have to do for this? We have to multiply it out first. So we're going to have 3x minus 2 times itself 3 times. So you could remember your Pascal's triangle, but we'll go ahead and do this. So let's take care of the first 2 together. So when I multiply the first 2, I get 9x squared. My outer and inner are both negative 6x, so I have minus 12x plus 4. And then I multiply by 3x minus 2. So now I take my 9x squared times everything. So I get 27x cubed minus 18x squared. And then I take my negative 12x times everything. So I get negative 36x squared plus 24x. And then I take my 4 times everything. So I get plus 12x minus 8. This is all still equal to y. I have not taken a derivative. This is just y. So I get y equals 27x cubed minus 54x squared plus 36x minus 8. Now take the derivative. The derivative's easy now. Well, besides hard numbers to multiply, can you handle 27 times 3? Yeah? 81. Phil's got this. 81x to the second minus. You're leaving me hanging on the rest of it? X.
0 or
So 108x to the first, right? And then plus 36. Yeah, and then plus 0 at the end, but we can leave it off. Does this make sense?
What if, okay, yeah.
You got it? All right, so that's where it gets a little tricky. What if it was to the 20th?
Like, what does this mean though?
This is the derivative for any x value. This is the slope at any x value.
Any x value.
Yeah, and slopes are important in real life because it's always a rate of change. So if I want to talk about bacteria growing, it would be the number of bacteria per hour, or gallons per minute, or feet per second. Anything that involves a rate. This is our debate that Mr. Morrison and I always have, because he's like, oh my gosh, AP Stats is more applicable to real life. And I'm like, seriously? Like, anything that has a rate of change involves calculus. Every single rate. Feet per second, miles per hour,
I think people use
gallons per minute. Yeah, I don't know. We'll see. If you're in the science world, you
Let's have a nerd fight.
use calculus more. Maybe ask Mrs. Adams what's more important. if you're asking a science person, they'll say calculus. Yeah. All right, so here we go. So number 5. So what are the powers? I don't know. It's weird. Okay, so we're saying it's f of x equals x to the 5 over 3 plus 4x to the 1/2. That's the square root, right? So we first write it so we have these powers, and then we take the derivative. Oh, going back to what I was asking you. What if it was a 20 there on that last one, number 4?
Nah, we don't think about that.
There's got to be another way, right?
There's a trick, isn't there?
There is a trick. Yeah. So this is what I do to you. I show you really long ways, and then I'm like, oh, there's a shortcut. All right, that's what keeps you coming into class every day. You just want to see these shortcuts.
Well aware of what you do.
I know. Evil. Pure evil. All right, so 5/3 x to the... So when I was in calculus, I remember having like marks all over my paper because I'd be like, okay, 5/3 minus 1. 5/3 minus 1 is 5/3 minus 3 over 3. Right? You can do this. 5/3 minus 3 over 3 is 2/3. And then I have plus 4 times 1/2 is 2. X to the negative 1/2. 1/2 minus 1, right? That's what we're doing. All right, let's try the next one. I love these ones. I love when there's like a monomial on the bottom. Now, if this had been like a 2x plus 1, we can't do it. We can't bring the 2x and plus 1 into everything. But if there's just a single term on the bottom, it can go into both of those. So we first rewrite it. So we're like, oh, I just have x to the 5th divided by the 2x, and I have the minus 3x squared divided by 2x.
Yeah, can you just pull up the 2x?
It's not like pulling it out. It's like putting it into both of them.
Can you just like, so it's x.
So cancel. So reduce. Yeah. So what's our number out front, though? What's the coefficient?
1/2.
1/2, because it was a 1 on top and a 2 on the bottom. So 1/2 x to the 4th minus 3 over 2 x to the 1st, right? X to the 1st.
Okay.
So what about g prime of x then? 2x to the 3rd minus 3 over 2. That's our answer. All right, if you can do the next one, you can do anything I throw at you. Try the next one.
I don't think.
So x to the 1/3 is the same as the cube root of x, right? So I have x to the 1/3. Then I have x to the 3 minus 5x squared. Now, I don't care what order you go in. Personally, I think it'd be easier if you took the 3x in first, but that's fine. We'll go with the x to the 1/3 because that's what most people would do. So if we multiply this x to the 1/3 in, we do not get x to the 1. People always multiply those powers. Right? If you have x to the 1/3 multiplied by x to the 3, what do we do with these? We add them, just like if I had x squared times x to the 5th, it's x to the 7th, right? So we're adding our powers. So what do we get when we do 1/3 plus 3? 4 over 3. So we have 4 over 3. You could also think of it as 3 and 1/3 and then do it that way. Well, actually, it's not 4 over 3. You're lying to me. It's going to be 9 over 3. So it ends up being 10 over 3. Should I do minus points when you throw me off and get me do the wrong thing? All right. Then minus 5x to the, so it's 2 plus 1/3. So if you think about it as 2 and 1/3, that's the fastest way, but you could also just, yeah, so it's going to be 7/3 over 3x. So now we're going to take that 3x into both pieces. So if you want to do like divided by 3x for both of them. Okay, so this is still g of x, not g prime yet. So our number out front is 1/3, and I have x to the, what do I get?
X to the third.
No. 10/3?
Okay, so
10/3 minus 1. 7/3, right? So x to 7/3 minus 5/3, x to the 7/3 minus 3/3, 4/3. So our final answer,
keep subtracting.
Caitlin, I have faith that you can do this. What do you think? Final answer, derivative. 7 over 9, x to the, subtract 1, 4/3, minus, x to the 1/3, good. Did you guys get that? Okay, we're taking the 7/3 times 1/3, which gave us 7 over 9. We subtracted 1 from the power, which gave us 4/3. We took our 4/3 times 5/3, which gave 20 over 9, and then we subtracted 1 from the power, which gave us 1/3. That's rough. All right, so last little bit. So find the points on the curve where the tangent line is horizontal. Underline tangent line is horizontal. What does that mean for a curve?
0.
It means the slope is 0. It's like a max and min usually. Not necessarily, but a lot of times. So we want our slope to equal 0.
Just kidding.
Can you just plug in 0?
All right, so we want to find where our slope, which is y prime, where's y prime or f prime of x equal to 0? So let's find it. So we have y prime is equal to, so looking at our y equals equation, what's our derivative?
3x.
4x to the third minus 12x to the first, right? I want to set this equal to 0. So I pull out a GCF. I pull out a 4
Very nice.
and an x. Yes, it was nice of me. And I have x squared minus 3. So I get x equals 0. And then what about the x squared minus 3? What do I get there? X equals plus or minus root 3. So sometimes on the AP test, you're done there. So it would be like, find the locations where your tangent line is horizontal. That's a location. That's an x value.
Are these points?
But I said find the points.
So you have to plug it back in.
So I want 0 comma something, and root 3 comma something, and negative root 3 comma something. So I go back to my y equals equation. Why do I not go to my y prime? That's the slope. It's not giving me a point on the graph, right? A point on the graph is our y equals. And if I plug those back into the y prime, I get 0 every single time. All right, what do I get when I plug in 0? So that's 0 comma 4. That one's easy. How about y of root 3? Root 3 to the 4th is 9 minus 6 times root 3 squared. So I get 9 minus 18 plus 4. It's negative 5, yep. Will I get the same thing for negative root 3? Yeah, it's called an even function. See how it only has even roots, or even powers? So you can try it, but you'll also get negative 5. All right, remind me to do the next one later. It's kind of a hard one. This is like definitely an AP type question. It's a tricky one, but we'll do that later. All right.